In this video I'm going to show you how I took an RC car and attached a Raspberry Pi and a USB webcam to provide low latency video over Wi-Fi. It's a ton of fun to drive. Let's get started. The first challenge is how to power the Pi. The car comes with a 7.4 volt 1500 milliamp hour battery, and it has two connectors on it. One of them is the main power connector with a positive and negative, and the other one is the balanced charge port with 3 leads. This one has 3 leads on it because it's actually a 2S configuration battery, which means there's 2 cells in here that are shrink wrapped and welded together. So I put some pin headers in here so we can hook it up to the multimeter and see what's going on. The main power connector is directly connected. We have a continuity test turned on here. Is directly connected to the red pins and the black pins. And the blue pin isn't necessarily connected directly to anything. So we switch to voltage. The main connector is going to be powering the car, so we can't use that without resoldering some wires. Oops, I mean to look at this one here. So here we have the full voltage, and we now know that over on the balanced charging port we also have the full voltage. There's no protection circuits or anything weird in the way. So if I look at the correct polarity, we know we can use this to power the Pi. So that leaves one question. What is the blue wire? The blue wire is connected to where the 2 cells are connected together. This is a 2S battery, which means 2 cells in series. So if we look at the voltage on black and blue, we can see that we will get 1 cell worth of voltage. That's just a little fact. Now we're ready to proceed. So now we need to knock down the power. What are we going to do for that? On Amazon you can get one of these awesome modules. This is a switching regulator as opposed to like a linear regulator, which would just burn off the extra power. This actually switches it so fast it drops the power that way, and it's extremely efficient. So you actually connect it in the corners. On the back you can better see. You've got in at the top, or I'm sorry, in on the right and out on the left. Positive on the top, negative on the bottom. And the negative or ground is just directly connected to the ground plane here. So you can see that's just fully connected all the way across everywhere here. And then the top pins are, sort of isolated on their own little islands. So let's hook it up. I built a small carrier board to allow me to do pin headers instead of soldering anything. It's pretty simple. Now we can connect the balanced charger port. Making sure, of course, ground to ground, red to red. And we've got the multimeter hooked up. You can see we're currently outputting about 3 volts, and we can adjust it right here with this screw. So right to go up, left to go down. We want to take it to 5 volts. It's really sensitive. Perfect. So once you got it locked into 5 volts, it's probably a good idea to secure it somehow. Maybe do a little bit of hot snot. Maybe not so much. And now that we're locked into 5 volts, we might as well label it in case we want to use this for something later. Bob's your uncle. Let's hook it to the Pi. The multimeter off. And I've trimmed down some DuPont connectors so that I can hook it to the Pi. We're going to connect it to the headers. Usually you power it by the USB port, but if you get one of these great pinout diagrams, 5 volts and ground are on the upper right corner. It's oriented like this. It's kind of crazy. So the first and the third pins up here we're going to use. And you can see why I cut it down. So once I put the case on, this will still kind of close up nicely. Plug it in. We've got the power light. We've got the activity light. And now I've got a Raspberry Pi running off of our RC car battery. Awesome. So I've already put this one in here, and this works nicely. Kind of like that. It's pretty secure. It's not super secure. And we're just gonna like twisty tie that over there, or something like that. Eventually, you know, when I progress to phase 2 of this project, we'll probably do something like a project box. I really like these boxes made by Hammond, these polycarbonate boxes that you can get on Amazon for pretty cheap, or if you're willing to wait, and you should, you get them for a couple bucks cheaper through a few other places online. So probably do something like the project box, you know, mounted on this side eventually in the long run. But for now, we're just kind of doing like a phase 1 dealie and just kind of getting this up and going. So now let's talk about the webcam. We want it to kind of be like, you know, like a Mario Kart sort of view, I think, where you're kind of like looking down behind it and at least see the front tires. So I found just putting it back here actually gives you that view. So I've got one pin or one zip tie down there. And of course you're gonna need some nice big old clippers. So that actually holds it pretty well, but this floppy part doesn't do, you know, what you want it to do. So I kind of made a little cardboard stick thing, and that kind of like rests nicely there. And that's kind of how I did that. So it's not taped, but obviously I'm just going to tape this down. I got some like Gorilla tape for the, you know, just right here and into the body of the car down there. And that actually holds the webcam and everything on there pretty well. So let's go ahead and just mount everything and see what happens. So with a little bit of Gorilla tape, this is held on pretty securely now. I'm happy with it. It's good enough. It's not going to be like, we're not going to leave it like this forever, so whatever. The power regulator is strapped down to the frame. We got the wire strapped down. This is pretty good. Everything's nice and tight. The USB is connected to the Pi now. And that's kind of just like okay dangling there. And we got the USB strapped to the front with the Velcro thing that came with the USB webcam, and attacked another zip tie down to the back, so it's held down and kind of forward. So that is super secure, not going anywhere. And that's pretty good. That's road ready. Now we can talk about the Pi that we're going to load on the software. We're going to load on the Pi and fire it up. I'm using Raspbian Stretch Lite. This is a cut-down version of Debian, which means we'll be doing everything command line. I'm going to open up a PuTTY session to access the Pi remotely. If you don't know how to do this, it's very simple. You just run sudo raspi-config. Go into interfacing options and enable SSH right here. Yes, you would like to enable your SSH server. Go ahead and exit. And the software we're going to actually be using to stream the video is MJPEG Streamer. A Google result will lead you to the original page here, which has been kind of abandoned, and now this wonderful gentleman, Jackson Liam, has taken over development. There's even very recent commits on this, so this guy's doing a fantastic job. And he has a wonderful README here that we can just kind of work through and get going. So we'll be using the Input UVC plugin, which allows you to use video for Linux devices such as USB webcams. You can see you can also use your Raspberry Cam directly. Very cool. So I'll also be using the Output plugin called HTTP, which is the protocol web browsers use. So that means I can serve this to a web browser and access it from pretty much anywhere. So why are we using MJPEG Streamer? Pretty much because I can access it anywhere. It's not the best, it's not the most efficient, but it works fantastically and it's very low latency. So let's go ahead and grab the source code. Let's copy the URL from GitHub here, and we will need to install Git if you haven't already. Sudo apt install Git, which I already have, but I'm just going to run through all the steps for you anyway. So what we want to do is use the git clone command and paste in the URL, and it's going to create a folder called MJPEG-Streamer. So you go ahead and cd into there when this is done, and proceed with the guide. So when you compile software, there's always dependencies. Here we need cmake and libjpeg 8 dev. Let's grab that. And if we look back at our guide, we're just going to cd into the directory. So if I do lsl, I can see what we just grabbed with GitHub from GitHub with the git clone operation. There's a directory called MJPEG Streamer Experimental. So we change into there and run the make command. Easy peasy. This one takes a long time, so sit tight. Okay, after the software is compiled, we're ready to go back to the guide and see what the next step is. Sudo make install. So generally after you run make, you have to run make install to actually make your binary available. This one's very quick. So now we can run lsl and see what we ended up with. Here we've got our MJPEG Streamer binary we'll be running. And the other important thing to kind of take note of is the www folder. So we've got our Raspberry Cam and UVC input plugins and our HTTP output plugin. So everything looks like it's compiled successfully. And we're ready to proceed with the usage. So there's two parameters here, kind of two pieces that are important. One is the export LD library path, which is telling telling MJPEG Streamer where these files are, where these SO files are. So in this case, if you just run dot, you're saying they're in the current directory. So we're gonna do something a little different because we need this for later. So we're gonna run the print working directory command, and we're gonna go ahead and set our LD path to that. Ooh, that didn't work, did it? Okay, copy that again. There we go. There we go. Okay, so now we can run MJPEG Streamer. And let's talk about command line flags. So MJPEG Streamer has an I parameter, which is the input, and you can see it's this long encapsulated string. So we're going to use the UVC SO module for input, using D for device, dev video 0, at a resolution of 1280 by 720, with F as a frame rate for 15. Not sure what N means. Let's move on. O is the output. So we've got the HTTP with the W parameter for the www directory. That slash shouldn't be there. And a port of 8080. So the www directory is kind of an important piece. It's going to tell you where the location of this www directory is. So because we're running this from within the MJPEG Streamer directory, we can just say www. And that'll be important later. So if we run this, it looks like it's working. So what if it's not working for you? Let's just close out of this. Oh, that said video and failed actually. Very nice. Let's troubleshoot. Okay, so if I run PS, I'm just looking if I have another instance of MJPEG Streamer running from maybe a previous demo. No. Okay, so the command you can run that's really important for this is lsusb, which is going to tell you all of your connected USB devices. So here's our Logitech HD Pro webcam C920. Perfect. That's exactly what we want to see. So another one you can run is dmesg, DMESG, which shows you kind of your most recent driver logs. So we can see when you plug in your USB webcam, it spits out all kinds of USB related events, and I can see right here where my webcam connected and is initialized. So this also looks good. If you don't see this, you got a problem. Okay, so what you end up with there is it makes a device at dev, and it's called video 0. So if we run dev vid star, we can see we do have a dev video 0 device. Okay, let's run our MJPEG Streamer command again. Okay, fantastic. So now that this is running, we can open up our web browser and pull up the IP address of the Pi at port 8080. And if we click on, oh, there's our picture. And if we click on stream, we can see a real-time video. So if we click stream, I can put my hand in front of the video. Hey, look at that, it's working great. And we could get a little preview to the next step of this and say, it looks like it's working. Ha ha ha. Fantastic. Okay. So, because this is a Raspberry Pi, and it's going to be connected to an RC car, we're not exactly going to be able to log in and run commands easily. We will have Wi-Fi, so, I mean, technically we could, but let's make this run at boot, is the point I'm trying to make. So how do you do that? You do sudo, run this command as root, nano for our text editor, and we're going to edit the etcrc.local file. So this is a location that you can put files or put a command that will run at boot. So if we want this command to run at boot, I'm going to put it right here before the exit line. And I forgot something, so let's go out here. And I need to make all these commands have the full directory now, because we're not going to be running them from within this directory next time. So I need to, get the PWD, and I also need my export LD library path variable to be set. Okay, so I'm going to copy that. Let's go back into rc.local. And I'm going to put that up here, right above MJPEG Streamer. Okay, so MJPEG Streamer is located in this directory, and our www directory is also in there. So I need to make this have the full path, and the MJPEG Streamer binary itself needs to be given that full path. Okay, so if we exit, save it, and now reboot this, this should be running at boot. Closed connection, of course, because we rebooted. Fantastic. Okay, let's go ahead and ping it so we can see when it comes back. For 400 millisecond timeout, let's ping forever. And when this comes back, we can confirm that MJPEG Streamer is in fact running, and then we'd be ready to proceed. Wouldn't that be great? Let's get on with it. This is just a Raspberry Pi 2, so it's a little bit slow. And there we go, now it's booted. Okay, so we can right click up here, go to restart, log back in, Pi, Raspberry, shh, don't tell anyone I'm using the default password. And we can confirm that it's running by running either the ps command with capital A for all processes. And hey, look at that, MJPEG Streamer is running. And you could also run the netstat command, sudo netstat, with, you want to see numeric port numbers, we want to see the listening ports, because this MJPEG Streamer listens on port 8080, and we want P for the process name associated with the port. And there we can see MJPEG Streamer is in fact listening on port 8080. So we go back to our web browser, refresh the page, and we still have Mr. T-Rex. Where'd my jaw go? Holy shit, I don't know. Fantastic. Now we're ready to proceed, attach to the car, and start playing with it. Plug in the power board, matching red to red, black to black. Plug in the car power, flip it on. This big red switch here. Car's now on. You'll see the webcam is dark. Doesn't have the blue ring around it yet, which means it's not powered on. MJPEG Streamer is now launched, and you can see the blue light on the webcam is now lit up, indicating that the video stream is active. So now we can dial into the Raspberry Pi over the Wi-Fi through the URL that MJPEG Streamer is going to be broadcasting on. So just type in the Pi's Wi-Fi IP address, port 8080. Look at that. MJPEG Streamer is running. So click on stream, and then there's a little link that says here that gives you a full screen stream. Otherwise you see it. You do see the video feed down here. And whoa, there it is. Put my hand out. Very real time, very cool. So now we can kind of adjust the webcam too to point downwards a bit. If we want that like camera, like car wheel Mario Kart type feel. If we turn on the remote control, now we can turn the wheels. You could see just how real time it is. It's really good. There's probably like maybe 200 milliseconds of latency. I don't know, I'm guessing, with totally no scientific proof there, but it's good enough that driving this car is possible. Let's take it for a spin. So we've got the car outside, got our live video feed going. Let's go take it for a spin. So I could pull the trigger, and pull it real slow. And I could drive it. It's good. Just gotta kind of go real slow, just because it is pretty fast and the trigger is pretty sensitive. But this is really drivable. The latency is not bad. So there you have it. Raspberry Pi RC car with the Wi-Fi video feed. Oh, now my Wi-Fi signal I think is going out a little bit from my house and the RC car, but it's very drivable. Isn't that awesome? So, thanks for watching.